Welcome to this class of physics. Today's chapter is beats. In sound, we are going to discuss about beats. What are beats? How beats are formed? How they will be observed? Can we give an explanation with an example? What are the uses of beats? These are the concepts which I am going to discuss. Beats are produced due to the superimposition of two sound waves of nearly equal frequencies. Beats are produced by the superimposition of two sound waves traveling in the same direction with nearly equal frequencies. They produce beats. Let us consider two waves of frequencies N1 and N2. When they get superimposed, the type of wave that is produced is known as beat wave, as shown at the right. A beat wave, when observed, we notice a large sound followed by a low sound. The large sound is known as waxing and the low sound is known as waning. So waxing and waning will be produced one after the other. And the time interval with which waxing is produced is known as beat period. If N1 and N2 are the frequencies of the individual waves that superimpose to produce the beat wave, then the period is given by 1 by N1 minus N2. This is the period with which waxing are produced or waning is produced. The beat frequency, that is the number of beat waves produced, is N1 minus N2. Here, when we say a beat wave, we have to imagine that it is composed of a waxing and a waning. A beat wave is composed of a waxing and a waning. And the number of beats that can be recognized is when it is less than 10. We can observe beat waves only when the beat wave frequency is less than 10. If the beat wave frequency is more than 10, we cannot recognize with our ear. Now let us consider two sources A and B. A is emitting a sound of frequency 20 Hz and B is emitting a sound of frequency 22 Hz. When both of them travel along the same line towards the observer X, then the observer notices beats. So beats will be formed when these two waves move together and they get superimposed and they reach the observer. To understand this beat wave, formation of the beat wave, let us take an initial state. Generally we say initial state is defined as t is equal to 0. Suppose at this time a compression of the sound wave produced by A is reaching the observer X. Also, a compression of the sound wave produced by the second source B is also reaching the observer. When a compression meets a compression, then a large sound will be produced, that is, waxing is produced. So this waxing will be, a loud sound will be noticed by the observer. This is known as constructive interference. So waxing is produced due to constructive interference, and the type of wave that will be observed by the observer is as shown in the figure. Let us consider after a time 0.25 seconds. We have defined initial time as t is equal to 0. After 1/4 second, 5 waves of the sound wave produced from source A will cross the observer. That means a compression of this source of the sound comes to the observer. Then 5.5 waves from the source B will cross the observer. That means a rarefaction of the sound from this source will arrive at the observer. So a compression of A and a rarefaction of B will be arriving at the observer after 0.25 seconds. So when these two mix together, superimposed together, they produce a destructive interference. because a compression is meeting a rarefaction and a destructive interference takes place, thereby a low sound will be noticed. This is known as waning. So a waning will be observed after 1/4 second, that is after 0.25 seconds. The type of wave that is noticed by the observer is as shown in the figure. So large amplitude indicates waxing, and small amplitude indicates waning. If the amplitudes of vibrations of these two waves are equal, then a zero sound will be noticed, which is represented by the horizontal line. If we observe after half a second, after 0.5 seconds, the starting time, initial time is taken as t is equal to 0. Now if we observe after 0.5 seconds, then 10 waves from source A will cross the observer. That means a compression of the source will arrive at the observer, and 11 waves from source B will also cross the observer. So another compression comes to the observer. Hence, a compression meets a compression, and thereby a constructive interference takes place. So once again a waxing is produced. A waxing is produced once again after half a second. This is shown in the figure as a large amplitude arriving at the observer. We have noticed at time t is equal to 0, a waxing is produced. After a time t is equal to 0.25 seconds, a waning will be noticed. Again after t is equal to 0.5 seconds, waxing is noticed. Similarly, we notice waning after a time t is equal to 0.75 seconds. Another waxing will be noticed after t is equal to 1 second. Like this, we will be noticing waxing and waning with a time gap of 0.25 seconds. Or the time interval between two waxings is 0.5 seconds. The time interval with which waxing is noticed is 0.5 seconds. This is the period of the beat wave. And the frequency is 1 by period. So 1 by 0.5 is 2. So the beat frequency is 2. This is nothing but the difference in the frequencies of the two waves. 22 minus 20 is also 2. So the difference of the two waves, frequencies of the two waves, is the beat frequency, and the reciprocal of it is the period. The phenomenon of beats can be used. The phenomenon of beats can be used for finding the frequency of a tuning fork. For determining the frequency of a tuning fork, this phenomenon can be used. And the presence of dangerous gases in mines can be detected. The presence of dangerous gases in mines can be detected with the beats phenomenon. Unknown frequency of a sound note. Unknown frequency of a sound note is detected by using beats phenomenon. This phenomenon is also used for tuning musical instruments. Like this, we use beats phenomenon. Let us summarize what we have learned so far. Beat waves are produced by the superimposition of two sound waves traveling in the same direction. Two sound waves traveling in the same direction with nearly equal frequencies, they get superimposed. Then the beats will be produced. Beats are composed of waxing and waning. Waxing is maximum sound, waning is minimum sound. So whenever compression meets a compression, waxing will be produced. Whenever a rarefaction meets a rarefaction, waxing is produced. And waning is produced whenever a compression meets with rarefaction. If N1 and N2 are the frequencies of the individual waves, then the beat frequency is the difference of N1 and N2. And the beat frequency can be noticed. Beats can be observed only when the beat frequency is less than 10. If it is more than 10, it cannot be recognized by the human ear. It can be used, the phenomenon of beats can be used for finding, for tuning musical instruments, finding frequency of unknown tuning fork, and the presence of dangerous gases in mines, etc. These are some of the applications of beats.